All right, so basically, last week on wait no, when did we do this? What's today? Today's Tuesday, right? So we're back on normal schedule. So Thursday, we essentially wrote this code to try and build our monad for state. And what I was thinking about prior to stream is like maybe I should test that this is actually the correct implementation. I'm pretty sure it's correct, but not 100% sure. Also, before I get started, I should shout out 2 new followers. So we're actually almost at 100 followers. Hopefully we'll get that. I mean, in theory, you could get that today. I just have to sell myself, I guess, to try and get those extra 2 followers. Yeah, so that was N Bardiak, who I don't recognize that name, but this other one, Simon Shine, I think is the one that's helping us with our pull request for exorcism, actually. So we're going to be working on that on Thursday. So that's kind of exciting. Now, to test this code, I'm also hoping that World's Ender is here at some point, so I can ask him about the ending of this. We wrote all this code, and essentially the cool thing about this was we're just using fmap to implement monad, but I don't understand exactly why I did this. It was very interesting. We had a lot of fun. Doing it, but I just don't know what it means. So, or I don't know the entire point, and maybe hopefully they can clarify that to me. But this is sort of the dumb implementation of the functor applicative and monad for state. And I was thinking, like, what if we tested it? And so I quickly wrote the sort of shell to test it, but you can see we're failing here, and it's probably because we don't have module main where. But technically this isn't a main module, but that's okay. I think this should be fine. So that was probably the bug we were facing. Except we have to implement all of these instances. And the one I don't know how to implement is, what's up, a mathematical way? Andrew, right? You use my first name, so I should try and use your first name. I think it's Andrew. You can correct me if I'm wrong. Great. So I'm just discussing how I don't want to write this instance, or these instances, because it's tricky. And we also need co-arbitrary because we're generating functions. And although int may already have a co-arbitrary instance, but really we're generating functions of tuples, which should also probably have a co-arbitrary instance. But I'm not sure I entirely want to spend time on this today. So what I was thinking about doing is just writing the stub, and then maybe we can fill this in if we finish the chapter. That's what I was thinking. So I'm going to ignore this for now. Okay? And what we're going to do is we're going to keep reading. Also, I got a new chair. I was complaining about my chair a few times, and if I have to complain about my chair, then it's worth getting another one. So I got this really comfy chair now, and it's pretty nice. So we'll start reading. Yeah, it's I'm yet at the point where I would recommend someone else buying it, because I literally got it today and I just set it up. But it feels pretty good. Feels pretty good thus far. It's better than the other chair, that's for sure. Yeah, sure. That's the key. You got to get the microphone, then you got to get like a decent microphone, then you got to get the I don't know, the video camera, I guess. I know you didn't want to be seen today, and then you got to get the chair. That's step 3, I think, in the thing. What I really need to do is get folks to help me with the emotes and stuff, because I don't know what to do for that. I think the emotes are fine, I guess. All right, so anyway, state operations. So since we know the internals of the state monad, we could inspect or update the internal state directly. For example, I want to do this outside of the lib. So actually what I think I should do is move lib to state.hs and then fix that and then recreate lib. Because we basically we just want to use our state from here without corrupting this particular file. Right, and then that will get us basically what we need to get started. Also, hello other viewer, I hope your day is going well. So anyway, with a state, we could do something like this. State int state sure, you can call it I. My goodness, I can't type right now. There you go. So we could write something like this. Except this is not a good idea, so we should write this is a bad idea. Why? It's a bad idea for the exact same reasons that it is not a good idea to access private methods from a module or a class. Similar to modifying private data. Oh, sorry, access. Classes with a Z, because they're cooler now. Nice. Okay, so instead, we should use the functions that state provides as an interface to build stateful computations. Doing so will pay off very soon. We will introduce, pay off very soon when we introduce monad transformers in chapter 11, which is what I'm really excited for. Once we get to monad transformers, I think we're gonna really get the meat of this book. Okay, so the interface for state is comprised of 3 functions. Oh, that's okay. Here, let me show you. Oh yeah, I'm in this. Okay, so I think, yeah, you can see this. So actually, the types that state gets represent a function. So this is actually a function int to int, but the type parameters given to the data constructor are just int and int. So yes. Yeah, so the interface of state is comprised of 3 functions, namely get, put, and modify. The names are self-descriptive. Get obtains the current value of the state and makes no change to it. Put performs the dual operation. It changes the state of the computation but returns nothing interesting. Modify also modifies the current state but does so by applying a function to it. Okay, so I'm supposed to write modify in terms of get and put, but I suppose technically I need to write get and put because I'm not importing them. So Yeah, so what we're gonna do is we're gonna write get and put for state here. Actually, I probably don't have get and put here. I don't want to do it this way. Okay, so we're gonna go. I don't want to go all the way down there. I want to go here. So we're gonna write get, which is going to be state ss. Why? Put, which is state s unit put, and then modify, which is modify undefined. Okay, so there we go. So let's read this. So get obtains the current value of the state, makes no change to it. Gets no state. New Maid asking the real questions. Are we doing something simple today, or are we melting brains? I think that we're doing something simple-ish today. We're kind of just working with what we have. It's chapter 6 of Book of Monads, so it's supposed to be. I don't think it's supposed to be mind melting. We'll have to see. So what is this? It construct. Wait, how is this get anything? I don't understand. I mean, that has to be the only way this type checks, right? Okay, I think I get it. So you're going to be given a state, and basically you're just putting it in the spot where A would be and returning state itself. Also, hello, new viewers. Well, potentially new viewers. We're trying to break our 100 follow goal. If you are feeling particularly inclined to help a small streamer. Okay, so yeah, anyway, so we're going to take a state and basically just put it in the A spot and then return the state again. So that's get, I guess. For put, we're going to take the state and return. Oh, there's still that tearing issue. I can see it on the OBS. Do you guys see it on your side? Ugh, I don't understand what that is. It was actually gone yesterday, so it only happens when I'm actually streaming. Can we call it a feature? If I like, oh, let's do it over here, I guess. I don't see it if I'm doing this, so it's something with NeoVim, it seems. Unfortunate. I don't really know what that is, so I apologize. Hopefully that's not too obnoxious. Except this is backwards, isn't it? Wait, what? No, I had it right the first time. Oh, I see. Yeah, but it seems to just be NeoVim. What if we just use it's less prevalent, but it's still doing it. So I don't, it's my terminal maybe. What if I switch terminals? Can I? Nice. Ooh, that font's kind of pretty actually. Oh, it's too big. It's a terminal. It's not doing it, right? Was it doing it? I don't think it was. Let's try this work in this terminal for a little bit. Did I leave something open here? No, let's get rid of this. This is color okay? Color seems really weird to me. But let's just try it for a little while and see what happens. So we were trying to write this, and essentially what it's saying is use tuple sections. So to use tuple sections, we just need to get rid of this, and then we need to, oh, we already have tuple sections, and we just need to get rid of that. So that's the tuple section version of put, I guess. So this one is going to take a function of s and return a state where fs is applied to s. Right? Now, the trick here is that we're not supposed to write that. We're supposed to write modify in terms of get and put. So it should be modify prime equals do. Does anyone else see it? I wasn't looking very carefully, but if you still see it, let me know. It seems like it's Terminator, which is unfortunate because I really like Terminator. This terminal doesn't split or anything. It's probably fine. Okay, so we're going to write what? Something like Terminator terminated. Yeah, apparently. I know, like, it's a Python application, so that's the only thing I know about it. And it has native splitting, right? That's why I like it. Right, you can do that to infinity. That's why I like it. Not that that's particularly useful, but you know, splitting even just half. And the other thing is you can move these things around. So like they move around. Maybe. I might be able to. I should probably, I mean, I definitely can do it with tmux, right? I should probably just learn how to use tmux better. I'm too reliant on my mouse. Okay, so we're gonna say like, we're gonna construct a state and then we're going to put and then I guess we're going to fmap fs Wait, did I have the shape of put wrong? I might. Yes, I do. That makes more sense. I was like, wait, how can I possibly put I? Doesn't make any sense. So this becomes... What do I do with the old state? I must just throw it away, yes? We'll have to look at new of him later. I'm gonna do that off stream for sure because huh. Okay, so oh, fmap would change the A, not the S. It's really put FSI. Think. Yeah, so fmap there wants to modify A, not S. So to update the state, you need to first get it and then apply it. Why does this shouldn't type check, should it? Well, we can look at it. So 43G. So we know the type of FS, obviously. What's the type of I? It's just an S because we're binding. We're binding, right? So get will give us a state, but then we're binding to extract the state because its type is SS, right? We would normally get an A, but because we're using get, we get a SS. And then we modify that S with FS and stick it back into a state. Does that make sense? Anyone have any questions on that? I mean, it's literally the same as this. We did put something. We put S, the new S. Leave U/S. I'm not sure what that means. But you have to put something. I assume you're not talking about here, but I'm not sure where. You'll have to explain a little bit more, Newmaid. I'm not 100% following. Okay, so that's that. Neat. I think it's right anyway. I don't see how else you would write it. All right, so we'll keep going. So a value of type state SA describes how to obtain a result value and a modified state. Oh, sorry, hang on. So this is like exercise 6.2. And then sort of this is like the, what do we want to call this? This is like same as above, but in lambda form. Right? Oops. Okay. So interesting. So let's keep going. So a value of type state SA describes how to obtain a result value and a modified state given an initial value. If you want to execute the action, you need to provide the value. There are a handful of ways of doing so depending on whether you are interested in the result value, the result value, the resulting state, or both. So we got some more functions to implement. By the way, these aren't exercises in the book, but I'm writing them anyway. Oh, we have run state, that's defined for us. There's also eval state. I like implementing functions, so I want to do that. That is a super nice purple. I love this purple. It's a really pretty color. I'm a big fan of the color purple. Ugh, S. Can't type today. I also just noticed something. I think both Andrew, a mathematical way, and I grunt when something wrong happens. We both go, ugh, or something like that. We just don't see Andrew's face when he does it. I just noticed that. Is that a Haskell thing? Do you do that, new maid? Observations. I actually really like this color scheme now that I'm looking at it more. I didn't like it at first, but I'm actually okay with it. Do we have any other options? I don't really want to change this. Oh, I see. Okay, so we could like check. I mean, that's like, does it automatically change? No, it doesn't. How do I profiles check preferences? I'm just curious real quick what the color schemes are. That's not terrible. That's awful. Sorry. I didn't mean to blind you. Tango dark looks fine. That's a little dark for my taste. Sorry, we're just for reference. That's awful. Apologies. Not trying to blind you, I swear. Nah, honestly, I like the other one. I don't know, some sort of custom color. How do I get rid of this? Delete. Delete. Okay, we're done. So back to code. So we're gonna quickly write these. I don't think it's gonna be very hard. We're gonna have the following. We need to run state SSA apply that to S and then take first because we want A. Yes? And this one's essentially the same function, just with second. And I don't know why, I mean, you don't even need these. Oh, wait. Yeah, I guess I do. Kind of. We can't compose. There's a way to do this. What is it? That's the question. Um, so we need to feed the function here first and then do this. It seems like there should be a $sign somewhere, but what is it? Is it like something like this? Oh, there's that thing. I forget what it's called though. Something about point free helper. This is useless. What is that thing that gets you the point free IO? It's probably this. I knew it was something clever like this. Not that clever, I guess. I need to think about it a little bit. Let's think about it. Okay, so can I... That's to resolve the whole thing, right? I can't get the dot, no. There's a Vim plugin to the point free tool as well. Oh, that would be sweet. All right, now I need to think about this. So what is the type of this? Yeah. I didn't realize that there was a command line version of this. But point free has more points. Neat. Star, yes, please. Oh, if people want this. There you go. Yeah, we should set this up at some point. I'm not gonna do it right now, but I definitely should use it. Okay. Oh. Ugh. So I need to make a new terminal, right? And then okay, I can still do that at least. I just don't like flipping between tabs like that real quick on you guys. I feel like is it jarring to your mental process? It seems like I mean, it's jarring to me even. So type first dot. That's run state. Okay. So here I would have to put the dot first, like this. So Lumi. Yeah, we didn't all say Lumi's here. We should say that. It's important. What's A? A is, this is the state. We're going to give this thing this function, which is run state. Which takes, what's A1? A1 is the state itself, and A2 is A1 is the state itself, and A2 is the S. And then we're getting the C back, completely ignoring the B. Right? Right. Okay. This is not entirely intuitive to me. I think this might be, for my particular brain, and mostly because I haven't looked at this a lot, this might be less readable than the other case. But, I mean, if you look at the type, it makes perfect sense. If you look at the type of this, and then this, like, you just progressively start applying the type macro. What's the right term for this? Statement, apparently. You just use the type statement and just look at it progressively. I think it does make a lot of sense. But this might be Pifsoff. This has got a little bit of Pifsoff smell for me right now. So anyway, okay, so we wrote that. And by the way, in the book, they write the version that I had first with SSA here. Okay, so as an example of usage of the whole state interface, let's look at the execution step by step of the following code. Okay, so now that we have all of those pieces, we will look here. With respect to color theme, I tend to really like the base 16 collection, especially because of the portability with 16 color terminals. I don't know what that means. Is that what I'm using? How do I know what I'm using? I've never used that before. I'm probably using, I don't remember the command to even look at that. Import it into the color palette setting for your terminal. I mean, we could look into that. I could do that. Yeah, that's what I was gonna say. I'm pretty sure that I'm using 256, and I know there's a way to find that out on the command line. I just don't remember what it is. It's something to do with, I don't remember. It's probably it's probably in here somewhere. Yeah, term. There are cases where I need to set this different sometimes. That's the only reason I know about this. Anyway, we're off the beaten trail again. So, okay, let's actually go in here, go back here, and we're going to look at the following code. Run state do, hang on. Okay. Some terminals also support 24-bit color if you really want flexible schemes. Thing with 256-bit is that the color choices aren't all that nice, in my opinion. Yeah, see, I'm okay with these colors thus far. I actually really like the pastel background. Like I don't like the deep black background. I like this. I don't know if pastel is the right term. That's always the term I use, but it looks a lot like Grovebox, which is why I really like that. Um, but I guess maybe this is pastel-y is the right term. I don't know. I'm not an artist. Okay, so what is this thing doing? So we are essentially building a state that contains XX and giving it S. Very picky. Fair enough. Something about this slightly lighter background I really enjoy. Um, Maybe it's not good for everyone, but I don't like the dark black. It makes me sleepy. Really? You monster. For for presentations, I will agree that light themes are best. Like if you're ever doing something on a projector, you can't use dark themes. But I really don't like. I think light is too bright. Although again, I'm not watching this, so maybe it's anyway. We're way off on a tangent. Um, anyway, this I think is pretty obvious. We're getting our A and then just returning it. So we're just gonna get back this, and if we change this to 1, well, I can't do this whole thing. We'll get 1 1, I think. Yeah. So by just using get, essentially you're always going to end up with SS. So this is really, I'm sorry, this is really an A in SA. And then because we're just returning it, the only thing you can do is make a like return state I mean, I guess it's this, right? I'm sort of forcing it to be, but that's essentially what it's doing. It's just sticking the A back in. Okay? But what we're going to do is we're going to start plugging in pieces and break this thing apart, okay? So that's what we're going to do. That code that I just wrote, this code here, is equivalent to doing a bind. So you can write run state get bind x return x 0, right? That's the same exact thing. That's what the do notation is doing for us. Is abstracting over this bind operation. And then we're going to start filling this in. So if we have get, essentially that is exactly the same as state s ss close parentheses, right? So we're just filling in this get operation. And if you run this, you'll still get the same thing. Then, oh gosh, I don't really want to type this whole thing. Maybe I should do it in an editor. It'll be a little bit easier. Yeah, so what we're going to do is we're going to take, let me put this in an editor. I was hoping I could just do it on the command line, but I don't think I can. So we're going to step by step change the following code. So run state And let's put this in, I don't know, some function just for now. I hate that so much. My computer's too fast. If it was slow, it wouldn't matter. Complaining that computer is slow. Funny. So I'm going to call this A, and we're going to get, and then we're going to return A. First world problems. Exactly. He gets it. Oh god, that's terrible. Oh, this is so awful. Hang on. What is this complaining about? Oh, sorry. I'm an idiot. Okay. Oh, they look terrible. I could. Oh, yeah. I mean, this is really going to be... And then this is going to complain. What does... That's what the formatter tells me. And yeah, this is a redundant return because we can just return get. So anyway, let's not repeat history. Jeez, dark. Why not put it in a where clause? We could do that too. We're gonna start replacing every piece of this. So I think that this is gonna be fine because it's going to change into a big mess. So I'm going to do that piece by piece. Okay. So the first thing we did was essentially get rid of the do notation and write this in bind. Okay, so that's going to look like the following. So you're going to say get bind a return a like so. Okay, so that's step one. So we've abstracted away the do notation. The next thing we're going to do is abstract away this. So that becomes basically state of S to SS. And then I think, what do we do next? By the way, somebody remind me what the term for this is. I wanted to call it beta reduction or something. What's that mean? Ada? Yes. I think it's beta reduction. So we are going to incrementally beta reduce. Let me stick this in here and then comment it out. And again, in comments it still does it, which is really annoying. Okay, there we go. Now we're set up. So we are replacing this. Then we are this step. I don't understand this step yet. I also don't really, I really don't like doing this like this. I'm having a hard time like connecting the steps this way, but I really do want to see. I actually don't want to write this. I don't want to do it. It's too much work. The final result is like, well, no, it's getting better. Okay, it's gonna get worse in this step. And I also don't see what we're doing. So we're gonna say S prime let I need this step written. We skipped I hate doing this. It's just tedious. Okay. Hopefully somebody else can understand what I'm doing, because I'm not even sure yet. So it's gonna be let so S S S S prime in run state we called it A. Return A. Oh, except I can't because we're using A up there. A okay. So what's broken here? Okay, cool. No, it's right. It's just complaining about this. I don't need this lambda here. Okay, so what did we do? That's the part I can't see. I think once we understand this step, the rest of the steps are trivial. Maybe. Wait, why is this written twice? What is this step? Okay, this step is us taking the s from the original state from the original state and applying it to we're embedding it into the new state. We're taking this lambda. Yeah, I can't do that. Oh wait, I can do that. Yeah, it's just gonna be an integer. So what we're doing is we're embedding this function into a new state, right? We're basically using the definition of bind. That's what we're doing. We're replacing the definition of bind with this let syntax. That's it. So it wasn't super clear to me at first. So all that's doing is, well, what state? This. That's all it's doing. So this is our FASBS, right? Run state. It goes there, and then we have let A and SAS 0. See it? We're replacing bind. I get it now. So this is for replace definition of. I didn't see it at first. It makes sense now. This one is basically replace okay. So 5. This is kind of hard to do on a stream, just for reference. So I apologize that this is really awkward. I imagine this is a lot easier to do in pen and paper. Okay, so this time we're going to apply run state. So this goes away, and this goes away. Well, we're applying the ignore this redundant bracket stuff. It's just HLint stuff. Sorry. Right, so we're just applying the outer run state, which just gives us this. And then we need to copy this. This is very awkward. Remind me never to do this again. So for 6, gosh, this is hard to read. Okay, so this step, we're going to replace s prime with 0. Okay, starting to get easier. So for reference, I see some new people watching. So what I'm doing right now is I'm doing the beta reduction for this function right here, which essentially is just like replacing all the pieces until you get the final result. And we know the final result is going to be 0. To that. Okay, that's what we're doing. So it's a little awkward to do on stream like this, but we have a type checker, which is nice because we know that it's working. Okay, now I presume the next step is we're getting a lot easier. Yeah, so the next step is just again using this replace a. I'm gonna probably wait. Do I want to skip a step? Is that what he's doing here? Yeah. So we're going to apply this function to 0, right? That's going to give us. Well, we can just write it. Let's leave it here. I'm going to do it all the way because I don't want to confuse anyone. Especially folks that may look at it later. So this function here applied to 0 gives you 0, 0, right? Replace a and s prime. Yeah, I would really appreciate that. By the way, you spelled that wrong, but that's okay. It's Barry with an A. I'm not a fruit. Although that's a really common mistake, but it's okay. Yeah, I mean, we're almost at 100 followers. It would be super amazing if we could push us over the 100, and I would be very grateful. Okay. We're gonna replace these. We're almost done. Right, so there's that. Then I assume we're going to we're going to apply the function again. Oh, also I need to take a drink, so we should do that. Beautiful. So if we apply 0 to this function, we should get state. Oh, I have it the other way. Sorry. That's the correct way. Then it's probably pretty obvious what's going on now, but anyway. So run state will basically get us here. Yeah. Oh, I got it. Oh no, that's right. And 11 apply lambda. We did it. So the trickiest transformation was this one, just replacing the definition of bind, because it just threw me off for whatever reason. And then once you get past that, everything else is really easy. We'll leave that commented. It's not particularly interesting. That's sort of just an exercise of the mind. Okay, so throughout the rest of the chapter, we'll look at several other monads. Their descriptions follow the same pattern as for state. A set of primitive operations on the monad, in this case get and put, some derived operations such as modify, and a function that runs or executes the effects provided by the monad. In this case, we have run state and variations derived from it. Okay, so we're just going to talk about some new monads, which is awesome, because that's what we want to do with this book, is talk about monads. Who wants to talk about monads with me? We're going to talk about the reader monad. The reader monad enhances a computation with a reference to an environment that can be queried at any moment, but in principle cannot be changed. The main primitive operation for reader is in fact the one that obtains or reads this environment. So let me bring up probably Hugel and look for reader. And it's going to be here. And we want to look at ask. Okay. This M in the case that we're going to think about is going to be identity. So actually, let's do this. I lied. What I'm doing is probably done. We're going to import control monad trans reader package transformers. It's gonna take a what? Okay. Apparently I've compiled transformers here before. So then we're going to write a type alias that is reader, which is going to be reader t s, not s, it's r identity r, reader r. Isn't it usually written this way? Okay, asks is written that way. Ask is written this way. So yeah, we should define reader this way. And then we need identity. Wait, really? There's no code action for that? That's interesting. Where does this come from? Data functor identity? Is it also in transformers? Painters? Okay. Suppose we use this one, yes? So this comes from data functor identity. Okay, so that's our reader. Okay, and then what we're going to do is look at the type of ask for reader R. Right, that's already defined. This isn't gonna work. Okay, it's not very helpful. I was really hoping that this would be more helpful. It's not helpful at all. I think we're gonna have to use it. Or we define it again on our own. What do we want to do? What exercises are in this part? Are there any? There really aren't any exercises? Gosh. Really unfortunate. What do we want to do here? Really don't know. The problem, okay, so the problem that I'm having right now, just for reference, is that there's really no exercise in the book. It's just like a wall of text, and I'm trying to make it more interesting, essentially. Um, I'm sure it's interesting to read because I've read it before, but I really want to make sure that do we want to just implement a reader? Yeah, let's just do it. Oh, I can't use new type. Wait, it's one argument and one data constructor, right? No, because I can do it with state, so it can be a new type. Style. I'll get the style right. So run reader is RA. Yes? Yeah, I mean, we're in the identity monad, so this is fine. We could just change identity here and it would be exactly the same. Maybe I should do that just to have it. We could implement the transformer, but I don't really want to do that. And I don't want to deal with the extra overhead of dealing with the identity monad. So let's just use RA, even though we don't really have to. Yeah, it's problematic, I suppose, when you use S there. What time is it? Okay, so what I'm gonna do is just put in the stubs for this, and then we'll implement them one by one. I remember the monad being a little tricky, but maybe my Haskell skills are higher now, and it's not as hard. So pure. Well, pretty sure this is just const. And we have what is it going to be? It's going to be reader to AB. So RRAB apply RRA. I think it's const. It might not be. We'll think about it here in a second. This is a good practice. Like, I always have issues with this. Oh, it seems to be right. Because it's just... Oh, I gotta wrap that in a reader. That's the problem. It's actually reader const. Reader.const, I think. And then we're gonna have the... Okay, so this should be reader, right? Like that. Because we're going to be given an A, so we just need a function that takes anything and makes it into an A. That's why it's const there. Hopefully that makes sense. I feel like I throw const around like nothing now. If that's ever confusing, please ask. And also, we write a lot of point free. NewMade has turned me, well, it's really NewMade and Lumi has turned me into a monster when it comes to point free. I've gotten pretty good at it, I think. There's still some cases where I have trouble, like the one we did earlier, but we're writing a lot more point free. Alrighty, so here we need to make a new reader, and it's going to be an R, and we need to get our A, so that's going to be RRAR, and then we just need to apply F to it. And this is really just F dot RRA, right? Oh, sorry, I have to actually pull out the reader, otherwise it doesn't work. But oh wait, I was gonna say, well, what if we just fmap? I can't fmap, right? I actually need to define the fmap to use fmap. I think we've done that before and created an infinite loop, which is fun. All right, so here it might be easier just to rip these things out. And really, this is no longer a reader RA, right? It's just an RA. So if we do here, we might want to leave the fmap ability. One of them we need to extract, so we'll figure out which one it is. Or one of these it will be easier to extract out. I assume it's going to be this one because we need the function. So I think that we really want to extract this, and we just want to do RAB fmap RA. Not quite. So this is an R to A to B. Which is not the right type signature. That's why you can't just do this. So actually, I think this is just easier to extract both. Also, I don't need these parentheses. Thank you, infix notation. And then we can just write reader R. We need an A, so we're gonna write RR RAR. That gets us an A, and then we need to convert it to a B. And R. Couldn't match type R with actual type A. Oh, wrong side. There you go. Yeah, I remember this being really hard last time, but it's not hard. So, right, this is an R to A to B, so we give it an R, and then we give it an A. It's the only way to do it. So, reader RA, and this function is pretty complicated. This is really, if I'm using the right, or if I use consistent terminology with what I've been doing before, it's really an f of A to reader RB, right? So we need a reader and an R. If we apply that, we get an A. If we apply that, we get a reader RB. And then we need to Okay. I think that's probably the cleanest I can do this, right? If it was up here, we could do a $sign and remove some parentheses. I prefer to remove parentheses if I can. So I just noticed a few people hopping on. So hello, my name's Barry. We write Haskell on this stream, so feel free to hang out or just talk about programming in general. Totally fine with me. It's more of an educational community than anything. And right now we are implementing the sort of standard type classes for the reader reader data type. I always want to say reader monad, but like it's more than just the reader monad. It's also a reader functor and a reader applicative. I think that's a really common thing a lot of people do. It's not just a monad, it's more than that, which is sort of useful. Any questions here? I think last time this took me quite a long time. And we did that in, I don't know, 15, 20 minutes maybe? Not even, right? Because there's only like 10 minutes. So we're getting better at Haskell, folks. It's beautiful. Okay, so now we want to write this function. Oh, this isn't pure. Wait. Oh, in terms of ask. I see. So we want this function. So what's the type of ask? Just reader RA. What goes here? Oh wait, this is R. Neat. Okay, so that's that. So those are the two asking functions, which we're probably going to use here very soon to build some stuff. We have run reader, which is going to take a reader and an R and give you back an A, which is what we have. By this point, you may have realized that reader can be simulated with state if you never modify the environment. This gets even more obvious once we discuss the implementation. Reader encapsulates the pattern of having one parameter in a function that is queried at several points but never changes. In most situations, the environment defines the global configuration of your application. Without this monad, we are forced to manage the arguments explicitly. let us consider the following piece of code. Okay. We'll just write that code. Noticed a new viewer. Hello, new viewer. We are learning about monads and Haskell, which is what this channel is good at. Well, that's what we do, I guess. I'm not sure I'm good at it. This is a fictitious, I'm not going to try and define these data types. It's probably, I mean, it's going to 100% fail. But anyway. Yeah, for anyone lurking also, reminder, I'm 2 follows away from 100 followers. I would appreciate if you just smashed that follow button. It would be really helpful and appreciated. Okay, produce response config initialize header. This code is not going to compile. I think we're using it as motivation for using reader. Nikito, hello, by the way. He's already a follower, or she, not sure. But I appreciate you anyway. You're already following, so we appreciate you more? Maybe? I guess? Not 100% sure. Probably. Okay. So I think we're okay. So essentially, we're going to refactor this as if we were waiting for a configuration. So I guess. So oh, there you go. Yeah, it's like boilerplatey, but I mean, I could also just refactor this, but again, this code doesn't compile, so we're kind of just using this as motivation more than anything. So I want to make sure I have this right, so we can at least discuss it. Header. Oh. Okay. Almost looks like C with a global variable if you squint hard. I've not written enough C recently to, I mean, sort of. For the config. Which line are you referring to? It's gotta be this line, right? Anyway, so okay, so we're refactoring this code to instead handle a request given some configuration, right? So this initialize header function takes configuration. So this now will just return a reader of some kind. The get arguments, we have to flip the order, but again, it's waiting for a configuration. Yeah. You have to in this case, right? Because this is now something you're waiting for. So this get arguments has to change physically. Otherwise it won't work. I mean, we could just write flip here if we really wanted to be super consistent. We could write flip get arguments rec, right? Again, this code doesn't really compile anyway, but you know, if you want these two to be consistent, you could do that. I think that's right anyway. And then produce response. Again, actually, let's not worry about this because all of your functions need to change, basically, because produce response here takes a config, and then essentially you're rewriting all of these functions to take config as its last input. That's what you're doing. And produce response essentially will return another reader. So this function itself is going to return a reader of config to response, and then you would just apply it to a config, and you would just get your response back. Well, you also need your request, but anyway. That's kind of interesting. So another way to look at reader is to think of it as introducing an implicit parameter, which is threaded under the covers by the compiler. Right, so this config just kind of gets threaded through, and then we deal with it at the end. It always remains the last argument, something like that. Yeah, it's actually they made a point. You can use state assuming you never change R, right? So you could just use a state where these two things are equal. Or I'm sorry, R never changes. It's exactly the same as state, really. So this was just like motivation. So think of config as being threaded through the last input argument. Something like that. I don't really like last input argument. That doesn't sound right. Let's just do that. Yeah, I sort of understand this a little bit more, I think, now than I did before. So we haven't really gotten to the stuff that I don't understand yet. Oh, well, run readers just implemented this way, right? So you basically have, well, this is obviously a little complicated, but this function here, or this whole function here, is producing a reader RB, and then when you run the reader, you're just left with this function. So it's just taking the reader with an R to a function embedded in it and just taking that out. And then once you have your function, you can just apply it to an R. So this just gives you a function, and then you just apply it. So that's how it's implemented. Yeah, any new type constructor has a data constructor. Wait, what is this called? What's the terminology? this is a data constructor. No, yes, this is a data constructor. That's a type constructor. This is a, what is this called? I mean, it's a record, right? Anyway, I think it's just a record. And this is record syntax. Anyway, okay. Terminology is hard sometimes. What are we doing next? We're going through another example, basically. Isn't that for data? Well, yes, you can, for data, you can just have multiple records. For a new type, you can only have one data constructor and one record constructor. I don't like that name. That seems wrong. Hang on. Oh, I already have something open. So new type Haskell. A field. So they're calling that a field. Okay. So data constructor, sorry, type constructor, data constructor, field. That's the terminology we're using in the Haskell wiki. Do they use field somewhere else just so I can, yeah, one field, one field. Got it. Sometimes typing things helps me remember it. So maybe I'll look at this later and be like, oh yeah, that's right. So terminology below is a reminder to self. Okay, cool. What's next? I think we're gonna do like another motivational type example. So here's one that has to be data, by the way. So just as a contrast. So Nikito, tell me why that can't be a new type. Quiz. You're welcome to not answer it if you don't want. Okay. At first glance, if you decide to take the route of using a reader to pass a configuration, you are forced to pass the whole of it to every operation. Sure. This forces multiple fields. You got it. Thank you for playing the game. Actually, for playing the game, hang on. How do I do this? Yep. All right, there you go. Why can't I click in here anymore? Cool. So, for playing the game, you get a sub. And that does put us to 6 subs, so that's kind of cool. Yeah, you're welcome, man. No problem. Yeah, so you gotta use your emote. So your emote is now, I think it's, you get this one. So just for reference. I think that's how that works. Yeah. Nice. So hopefully there'll be a chance for you to use your FMAP emote at some point. I still have not seen an FMAP emote used in chat correctly, except by myself in someone else's chat. I did it in Soding's chat once. Kind of funny. All right. Yeah. Well, I don't always agree with that. And the reason I don't always agree with that, Nikita, is that sometimes you can do point free, where it looks nicer if you write like fmap f whatever, and you don't need extra parentheses. That is the only time that I'll agree with you, I would say. If you can avoid parentheses and increase its point freeness, then I'm okay with prefix fmap. That's usually when I use it that way. Okay. Okay. Sorry, I need to add some motivational code here. This is not valid Haskell. Very hard to do this. Okay, what's going on, Oren? How are you? Can you instance functor using the symbol notation in the definition? Yes, you can. I'm not here, but I think you can. You might not be able to, actually. Hang on. Oh, well, the data definition is fine. Well, no, it's not, because I don't have any of these types to find either, so... Shoot. Trying not to swear. What am I doing? Jeez. No, you can't. That's right. So this is defined somewhere else. And this is a legacy reason for reference. It's not... let's go find out where that's defined, actually, because now I'm curious. there's for historical reasons you can't do that. So it's defined outside of the instance. That's the problem. So yeah, unfortunate. I forgot about that, but it makes sense. Like, I mean, you can look at the source code for GHC and find that. So it's kind of nice. But the instance actually expects you to define fmap. And if you get rid of it, I'm sure that the error is like, you don't define fmap. But we can read it. Yeah, well, we're done actually. I was just answering a question for Nikito. What we're trying to do now is motivate use cases, like practical use cases for Reader. But it's a little tricky because the code doesn't actually compile. So we did the functor, applicative, and monad instances already. And I don't know if you were here the last time we did them, but I had a rough time writing this one. I don't remember why. I don't remember if it was this one or this one, but like it came to me almost instantly this time. So I'm definitely improving, which is really like enjoyable to think about. Okay, so if you had a case like this, so you're building up some sort of query string, let's say, and then you actually run a query to get an R, then you do something else with the results, right? These are, I guess this is supposed to be results, and this is supposed to be your query string, something like that. You always have to write query in the following way. So it always requires you to take an entire config. So you could have some config that only, is only really user config or only DB config, I guess. So it would be nice if you could deal with these things separately, I guess. So the way you can do that is by using this asks function. So you could write like do db c for db config asks db config. Okay, so like you, in this case, you only really want to work with your database config, so you use this asks function to rip out the piece you need, and then I guess you put what's the hang on. Oh, I mean, there's like a queue here, right? Okay, so we could do this. Turns out you can. However, to make query unaware of any other configuration parameters it does not use, it would. Okay, let me read that whole sentence. DB config is here. So it's this data constructor. I'm sorry, it's this field from the config data constructor. Yep. So hang on. It would be better, however, to make query unaware of any other configuration parameters it does not use. That way we reduce the chances of introducing coupling between the different subsystems that is too strong. Oh, I see. So instead, it would be better if you did this. So db config, and then change this to ask. And I assume that doesn't change what you're doing here. So you could say like, there's dbc, and then you're saying let r equals run reader query. Wait. Not here. Sorry. I don't understand. I really wish this was a full piece of code that we could work with. Like, even if it was just junk hidden behind the scenes, it would make life a lot easier because there's so many dots. It's like, well, it says the problem if you do this is the implementation of handle no longer compiles. It's like, well, I mean, how do I know? Using this wonderfully statically typed language, but there's nothing to do with it. But that's okay. So essentially, there's apparently no way to bridge the worlds using ask. The only additional operation. Let me keep reading because I don't like where we're going with this, and it's hard for me to see the result. Oh, I see. Okay, it's motivating the following. Hang on, I think I see what's going on here. So instead of doing this, you can use this function with reader. Okay, so this now can do whatever it needs to do, but I guess this is gonna take. What is this supposed to be? This code is very confusing to me. And it's only because it's not full snippets. If it was full snippets, it would make sense. I think so. I think that's the point. So you can write something like let no, you don't even need that. That's your R. So yes. The part I don't understand is what is query here? Like, is it gone? I'm a little confused. All right, so anyway, this functionality is useful when the configuration is slightly different in part of your code. One good example is logging. For a certain piece of code, you might desire to have more verbose logging output than for the rest of your application. Reader. Yeah, like here you're supposed to do something with this DBC, and it's going to have to return a function of R to A. But yeah, I don't know. I really wish this was a whole. Oh, here's the whole code. No, it's not. I lied. You don't write. I don't know what the definition of query is supposed to be because it's changed. Oh, no. I lied. I get it. I get it. I get it. Hang on. I'll get it right. So this is the combination. So basically you're using this ask to get the database config. Yeah, I got you. And then this with reader function basically converts the reader from a reader config to a reader DB config with a result. And then you can just use R. Yeah, that makes more sense. That makes a lot more sense. Okay, so one thing we could do, I really don't know what to write here. It's kind of like zoom in on specific field, or use with reader to operate on a subset of fields. Example. Something like this. Okay. Now, next thing we're going to try and write is this. So R2S reader R SA to reader RA. By the way, these aren't actually exercises in the book, if I haven't made that completely clear. So looking at this looks like something that we've seen before, which is called what? It's not a bifunctor. It's a contra map, right? Where this R becomes maybe not. Maybe that's not right. For some reason, I'm thinking that because this is like an S to an A, and this is an R to an S. But maybe that's not. Maybe I'm not thinking about that correctly. Time to take a drink. Oh wow, it's 9:40 almost. Well, unfortunately, we didn't get any. We didn't get our follower goal today, but that's okay. We'll get it probably next time. Hopefully. What are we doing next time? Oh, we're doing open source contribution. Okay, so given an R, we need to given an R, so this is a function S to A. So we're going to use RS to create an S and an SA to create an A. Yep, exactly. I'm glad I didn't look over at the answer though. So, and this is just that. Okay, with reader, done. Let's finish this section and then we'll move on. Oh, never mind. We are done. Okay, so well, it would be this way potentially. No, I don't think so, because you need the lambda. Wait, why can't that? It can't be a dot. We need $sign here. Yeah. No, that's okay. But I like, yeah, at the end is definitely off. But at the beginning, like I was thinking, why is that not a dot? But you're not composing a set of functions. You're sticking a lambda inside of a reader, right? So you do need the $sign here, or parentheses. One thing I was thinking about is like, what if we don't pattern match here? Is there a way to deal with this? But because this kind of looks like, the problem is that it's backwards, right? Yeah, so it is actually like, I don't know if contramap is the right term. Let's look at contramap. Because for whatever reason, my brain is like thinking contramap. So let me make sure you can at least kind of read that. So we have an f of b of a. This is a b, a to b. So yeah, it's contramap. Right? RS, f of b, f of a. I think it's contramap. So I was right to think that. Anyway, yeah, so let me thank again N Bardiak for the follow and Simon Shine for the follow. I think Simon